Hi, everyone, welcome to my channel again. Today, I am going to share about how to perform GR&R. Before watching, please like, comment and subscribe to my channel. Measurement system errors. Measurement system errors can be classified into two categories. Accuracy and precision. Accuracy is the closeness of agreement to the true value or to an accepted reference value. Precision is the closeness of repeated readings for each other. Precision is independent of accuracy. That means it is possible to be very precise but not very accurate, and it is also possible to be accurate without being precise. The best quality scientific observations are both accurate and precise. If all of the darts land very close together, there is good precision as shown in Figure A. Next, what are crossed and nested factors? Two factors are crossed when each level of one factor occurs in combination with each level of the other factor. For example, the same three operators would inspect the diameter from both gauge. Two factors are nested when the levels of one factor are similar but not identical, and each occurs in combination with different levels of another factor. For example, if gauge 1 is at one location and gauge 2 is at a different location, each gauge will have different operators. Total process variation is broken into two sources: part-to-part variation and measurement system variation. Measurement system variation consists of variation due to operator or reproducibility, and variation due to gauge or repeatability. Under reproducibility, you can further analyze operator effect and interaction between the operator and effect. You can analyze the Gage R&R study using one of the following analysis techniques: average and range method and ANOVA. What is the difference between two methods? For ANOVA method, this method provides an additional test for the interaction between the operators and the parts other than operator main effect. However, for X-bar-R method or average and range method, no interaction study between the operators and the parts. How to perform GR&R. 1. Obtain a sample of n greater than 10 parts that represent the actual or expected range of process variation. 2. Refer to the appraisers as A, B, C, etc. and number the parts 1 through n so that the numbers are not visible to the appraisers. 3. Calibrate the gauge if this is part of the normal measurement system procedures. Let appraiser A measure n parts in a random order. 4. Let appraisers B and C measure the same n parts without seeing each other's readings. 5. If n trials are needed, such as 3 trials, repeat the cycle using a different random order of measurement for each operator. For example, QA qualifies a new test board before release to production. 10 parts are selected randomly from production. 2 operators measured the 10 parts with 3 times per part in random order. The upper spec limit, USL, is -77 while lower spec limit, LSL, is -83. The historical process standard deviation is 0.5. Next, I am going to show you the steps of performing GR&R study using Minitab software. Choose Stat, Quality Tools, Gauge Study, Gage R&R Study Crossed. Complete the following steps to specify the data for your graph. In part numbers, enter part. In operator, enter operator. In measurement data, select HZ. Click Options. In lower spec, enter -83. In upper spec, enter -77. In historical standard deviation, enter 0.5. This page shows Gage R&R report for HZ. Minitab uses the analysis of variance, ANOVA procedure to calculate variance components, and then uses those components to estimate the percent variation due to the measuring system. The two-way ANOVA table includes terms for the part, operator, and operator by part interaction. If the p-value for the operator by part interaction is greater than or equal to 0.05, Minitab generates second ANOVA table that omits the interaction term from the model. Percent contribution. Use variance components to assess the amount of total Gage R&R and part-to-part variation contribute to the total variation. Percent study variation. Use percent study variation to compare the measurement system variation to the total variation. Percent tolerance. Comparing the measurement system variation with the tolerance. Percent process. Comparing the measurement system variation with the historical process standard deviation. NDC. To identify a measurement system's ability to detect a difference in the measured characteristic. Percent contribution. Use variance components to assess the amount of measurement system variation total gauge R&R, and part-to-part variation contribute to the total variation. Total process variation is broken into two sources, part-to-part variation and measurement system variation. Measurement system variation consists of variation due to operator, or reproducibility, and variation due to gauge, or repeatability. Total gauge R&R consists of repeatability is the variability from repeated measurements by the same operator. Reproducibility is the variability when the same part is measured by different operators. This can be further divided into operator and operator by part components. Percent contribution. Percent contribution is based on the estimates of the variance components. The percent contribution for total gauge R&R is 8.36%, which is less than 9%. Based on AIAG guidelines, if the percent of contribution is less than 9%, the measurement system is acceptable. If the percent of contribution is between 1% to 9%, the measurement system is acceptable depending on the application, the cost of the measurement device, cost of repair, or other factors. If the percent of contribution is greater than 9%, the measurement system is not acceptable and should be improved. Percent study variation. Use percent study variation to compare the measurement system variation to the total variation. The percent study variation for total gauge R&R is 28.91%, which is less than 30%. Based on AIAG guidelines, if the percent of study variation is less than 10%, the measurement system is acceptable. If the percent of study variation is between 10% to 30%, the measurement system is acceptable depending on the application, the cost of the measurement device, cost of repair, or other factors. If the percent of study variation is greater than 30%, the measurement system is not acceptable and should be improved. However, the assumption for both percent contribution and percent study variation is the sample parts must be selected from the process and represent the entire production operating range. If the samples do not represent the entire production operating range, the percent study variation and percent contribution must be ignored in the assessment. Percent process. Use percent process to compare the measurement system variation with the process standard deviation. The percent process for total gauge R&R is 40.85%, which is more than 30%. The measurement system is unacceptable for process control. When to use percent process? If the samples do not represent the entire production operating range, the percent study variation and percent contribution must be ignored in the assessment. Use percent process to replace percent study variation and percent contribution to access the adequacy of measurement system for process control. Percent tolerance. Use percent tolerance to compare the measurement system variation with the tolerance. The percent tolerance for total gauge R&R is 20.43%, which is less than 30%. The measurement system is acceptable for product control. If you enter tolerance, Minitab calculates percent tolerance. Upper spec equals -77. Lower spec equals -83. Tolerance equals upper spec minus lower spec equals -77 -83 equals 6. Percent tolerance equals total GR&R divided by tolerance, which is 20.43%. The percent tolerance is the percentage of the tolerance taken up by the measurement system variability. Number of distinct categories. The number of distinct categories, NDC, is a metric that is used to identify a measurement system's ability to detect a difference in the measured characteristic. NDC is the ratio of the variability in the measured parts and the variability in the measurement system. The AIAG recommends that the number of distinct categories be 5 or more. The NDC is 4, which indicates the system is unacceptable mainly due to the samples do not represent the entire production operating range. If NDC is equal to 1, it is unacceptable for estimating process parameters and indices. The measurement system is of no value for controlling the process, because it cannot distinguish between parts. If NDC is between 2 and 4, it is unacceptable as well. When the number of distinct categories is 2, you can split the parts into only 2 groups, such as high and low. When the number of distinct categories is 3, you can split the parts into 3 groups, such as low, middle, and high. NDC equal to or more than 5 is highly recommended. In the components of variation graph, the percent contribution from part to part is larger than that of total gauge R&R, telling the largest component of variation is due to part-to-part variation. The R chart is a control chart of ranges that graphically displays operator consistency. If any points on the R chart fall above the upper control limit, UCL, the operator is not consistently measuring the parts. If operators measure consistently, the ranges are small relative to the data and the points fall within the control limits. The X-bar chart compares the part-to-part variation to the repeatability component. Because the parts chosen for a Gage R&R study should represent the entire range of possible parts, this graph ideally shows lack of control. For these data, many points are above or below the control limits. These results indicate that part-to-part variation is much greater than measurement device variation. Multiple measurements for each part show some variation, the empty circles for each part are not close together. Averages vary enough so that differences between parts are clear. The by-operator plot can help you to determine whether measurements and variability are consistent across operators. Here, the operators appear to be measuring the parts consistently, with approximately the same variation. The interaction plot displays the average measurements by each operator for each part. Here, the lines follow one another closely except part 5, and the differences between parts are clear. The operators seem to be measuring parts similarly. If lines are not parallel, or they cross, an operator's ability to measure a part depends on which part is being measured, and interaction exists between operator and part. The page summarizes the decision rule for percent contribution, percent study variation, percent tolerance, percent process and NDC, which are explained early. In summary, precision is the closeness of repeated readings for each other. The gauge is good for product control, evaluates part relative to specifications but not process control, such as process stability monitoring, experimental study due to the percent process being over 30%. If the samples do not represent the entire production operating range, the percent study variation and percent contribution must be ignored in the assessment. Use percent process to replace percent study variation and percent contribution to assess the adequacy of measurement systems for process control. Thanks for watching. Remember to subscribe to my channel. Bye. See you next time.